on to our third rigid transformation. It's not going to change the size or the shape, but may change the orientation. 9.3, the I can statement is I can understand and perform rotations. So let's talk about what the word rotate means. If you say rotate, if somebody said, hey, you need to rotate that or something, what would that mean they're telling you to do? Well, it usually means they're telling you to turn it. So let's write turn or spin. Either way you want to describe it would be totally okay. So let's fill out these blanks down below. So there are three important rotations that we're going to need to learn. When we rotate something, again, we turn it around a central point. So we turn it around a central point, and sometimes we say about a central point. The point we usually rotate around is the origin. Now, we could rotate around any point we want, but we typically rotate around the origin. And there are three rotations that we're going to be concerned with in this particular section, and some words we use to describe them. So we can do a 90-degree clockwise rotation about the origin. We can do a 90-degree counterclockwise rotation about the origin, or we can do a 180-degree rotation about the origin. So a couple quick things here. When we say the word about, what we mean by that is we mean around. So when we say about the origin, what we mean is spin this or turn this around the origin, okay? Around the central point. Okay, whatever point they're telling us to rotate it around, that's what we're talking about. We're talking about rotating it about or around that central point. And the other thing I wanted to mention here is if we rotate something clockwise, so let's take this one right here. Let's say I rotate that 90 degrees clockwise. That's going to end up right here. If I rotate it 90 degrees counterclockwise, it's going to end up right here. But if I rotate it 180 degrees about the origin, you'll notice we didn't say clockwise or counterclockwise, and here's why. If we're going this direction, we rotate 180 degrees, we'd be pointing down there. If we rotate the other direction 180 degrees, we're still going to be down there. If we rotate 180 degrees, we're going to still end up in exactly the opposite direction. So clockwise, this would be 90 degrees clockwise, so to the right, okay? Right, and this would be 90 degrees to the left if you wanted to think of it that way, and this is in the exact opposite direction, okay? And that's what, if we do a 180, you've probably heard of that before. If you do a 180, you turn in exactly the opposite direction. So I've got example one here. I do have just 3 points that we want to transform using this particular function mapping. I don't really feel the need to practice a whole bunch of these, but I am going to do this really quickly. So you'll notice that the mapping says that we should do this. Take the xy pairs and turn them into -x, -y. So we're not changing the order at all. We're keeping them in the same order, but what we're doing is we're changing the sign. So what I'd like to do is stick with that same type of notation that we did before. Put an arrow as far as the direction that we're going to go. Are we going to keep it in the same place, kind of coming straight down, or are we going to crisscross them and change places? And then if we're going to add or subtract, we'll put that, but if we're going to multiply, then we just put it in parentheses. So that means f prime is going to be this point. -4 times -1 is 4. -3 times -1 is 3. So notice that they stay in the same place. They just change signs. So this is going to get multiplied by -1, and this is going to stay in the same place but get multiplied by -1. So I'll do that on every single one of these. I'll go ahead and write that down. Now, if you don't feel the need to do that, that's totally fine, but please make sure you're getting the answers right. So this is going to be 3 times -1, that's -3. -1 times -1, that's 1. And then t prime would be, let's see, 2 times -1 is -2, and -5 times -1 is 5. Okay, so we got those points right there. We should be in good shape. That would be the answer. If all you had to do is just change the coordinates using that function mapping rule, that's all you'd have to do. Now on these examples, again, just like always, it says graph the image of the figure using the transformation that's given. Use proper notation for the image. So again, this is the old one, and then we want to make the new one. Now in order to make the new one, we have to follow these instructions right here, this mapping. And this is where it is going to be really useful to go ahead and write down what those points are. So I'm going to do I, N, and F, and we're going to write down each one of those coordinates. So this one is over 2 and up 4, so 2 comma 4. N is, let's see, over 4 and up 4, so 4 comma 4. and then f is over 2 and up 1. So over 2 and up 1. And here's what the instructions say. This is what the mapping says we need to do. We need to take the old xy pairs, and what we need to do is we need to make them y and negative x. So we need to switch the x's and y's, and whatever x was, we need to multiply it by a negative 1. If it used to be positive x, we're going to make it negative x. Okay, so here's how we're going to indicate that. They are going to switch directions, so we're going to go like this. We're going to draw an arrow. We're just going to put a 1 right here because it's not going to change at all, or actually because it's not going to change, let's do this. Let's not even put anything, because remember, if you don't put anything, it's assumed to be a 1. So we're going to move the 4 over here, and then we have to multiply this by negative 1. All right, so let's see what we get. So this is the new point, I prime. So I prime is, let's see, the 4 comes here. We're moving the y into the x place. So notice the y gets moved into the x place. And then we're taking the x and multiplying it by negative 1. So this is going to be a negative 2. 2 times negative 1 would be negative 2. Let's do the same thing again. We're going to switch this one over here, and we're going to multiply this one by negative 1. So n prime is going to be, move the y over here, that's a 4, and multiply the 4 by a negative, so that's going to be negative 4. Same thing again. These transformations are the same every single time. So move the y over here and multiply this one by negative 1. So this is going to be f prime. So we get a 1 comma negative 2. Now those are the points, and it didn't say you had to write those down. I mean, we do get some extra practice here. But without coming up with these points, it would be really tough to just say, oh, I know what that does. So let's go ahead and graph I prime. So I prime is going to end up here. I prime is going to be at 4, negative 2. So over 4 and then down 2. So that is I prime. N prime is going to be 4, negative 4. So we're going to go over 4 and we're going to go down 4. So that's going to be right here. So there's N prime. And then f prime is going to be 1, negative 2. So over 1 and down 2. So we're right here. So that's f prime. So that one is the old one up here. This is the new one. So let's think about what happened here. If we had to verbally describe what happened, this used to be kind of pointed, kind of a wedge shape with the end pointing off to the right. Now it's a wedge shape with the end pointing down. So it used to point over here, now it's pointing down here, and let's think, that's kind of a 90-degree turn. So one way you can do this is, if we were to put a point right here and we spin this paper 90 degrees to the right, this point, so let me show you, this point would spin over here to I prime. There's a 90-degree turn in the clockwise direction. Okay, so that is what this represents. This is a 90-degree rotation clockwise. Clockwise, all one word. Okay, 90-degree rotation clockwise. All right, let's take a look at the next one. The next one, we've got these points right here. And the rule says that we need to change xy into negative y comma x. Okay, so let's see what happens here. So we're going to do BEL. So we're going to do B and E and L. And the point B is, let's see, over 5, didn't go up or down, so that would be 5 comma 0. You are going to have problems like this on the test, I guarantee it, so make sure you can do this. So we've got to grab the points from the graph, so that's over 3 and down 1, 2, 3, 4, 5, so 3 comma negative 5. And then L is over 2 down 1, so that would be 2 comma negative 1. Okay, now the rule says that we are going to take xy and we're going to change it into negative y comma x. So they're going to switch places, and the y is the one that changes sign. So here's what we're going to do. The x just gets switched over here. We don't have to multiply it by anything, but the y comes over here and we're going to multiply it by negative 1. So here's B prime. The 5 goes over here. We just move the x in the y place. We multiply the y by negative 1. 0 times negative 1 would still be 0. So we got that one. Okay, here's going to be E prime, and here's going to be L prime. We'll just go ahead and get these all set, and we'll write down the work. So this one's just going to come over here. This one's going to get multiplied by negative 1. The x is going to come over here. The y is going to get multiplied by negative 1. So let's see what happens here. The negative 5 times negative 1, this would be a 5. The 3 just gets switched over here. The 2 just gets switched over here, and the -1 gets multiplied by -1, so that's a 1. So I kind of did that in a little bit of a random order, but the 5 is going to come over here, the 3 is going to come over here, the 2 is going to come over here, and then every one of these got multiplied by -1, so you can see that the sign changed. So let's go ahead and graph this and see what we've got and see if we can get a verbal description of this. So B prime is going to be at 0, 5. So 0, don't go right or left, go up 5. So that's going to be B prime. Now, before we do anything else, we might want to think about, well, how would we go over here? We could do a reflection or we could do a slide, but this is in the section on rotations. Think about how we would rotate that. We're probably going to rotate it that way, and think about how many degrees would be right there. So you think about that, and then we'll come back to that in just a second. Let's do E prime. That would be 5, 3. So over 5 and up 3. So we'd be right there. There's E prime. And then L prime is 1, 2, over 1 and up 2. So there's L prime. So here's the old one, and here is the new one. So here is the new one. So gosh, this looks, man, that looks like it could be kind of like a reflection or something like that. But you'll notice that these don't match up. That is L, but that's not B. So this is definitely not a reflection. This is a rotation. So look, we rotate 90 degrees to get up there. We rotate 90 degrees to get up there. And again, if we needed to, you could do something like this. Draw a little line back to the origin, because that's the point about which we're rotating. And then draw a line over here. Look, that's a 90-degree turn going this direction here. So let me go ahead and erase that. But I'm hoping that you can see, if we were to take this and put our pencil right on this dot, we could spin this around, and then the E would be pointing, instead of down here, it's pointing out there, 90 degrees away from where it was pointing before. So we went this direction from the old to the new. So this is going to be rotate 90 degrees counter clockwise. Rotate counterclockwise 90 degrees. Okay. All right, let's take a look at this last one on the page. We're going to take these points and we're going to, let's see, switch the x to a negative and switch the y to a negative. So in other words, multiply each one of them by a negative, but they don't change places. So let's go ahead and write down what we have. So let's do, is that an L? Looks like an L to me. So we're going to do x and c and L. So x is the point back 3 and up 2, 4, 5. So -3, 5. C is the point, don't go right or left, just go up 2. So that would be 0, 2. And L is the point, let's see, we go back 5 and don't go up or down. So that would be -5 for an x coordinate and 0 for a y coordinate. And then the instructions say we do this. X is going to stay in exactly the same place, but we're going to multiply it by a negative. Y is going to stay in exactly the same place, but we're going to multiply it by a negative. So we'll indicate our shorthand like this. And again, if it's helpful, and for some people it is, if we just go through and write down all of the rules on this, that might make things a little quicker. So literally all we're doing is we're multiplying every single one of these coordinates by a negative. So this is L prime here, and we've got all the spaces. So this is cool. All we have to do is multiply down. So -3 times -1, 3. 5 times -1, -5. 0 times -1, 0. 2 times -1, -2. -5 times -1, that would be 5. And 0 times -1 would be 0. So let's go ahead and graph these points and see what happens here. So this is 3, -5. So 3, -5. That is x prime. Okay, now we know this is in the section on rotation, so let's stop and think about this. If I were to draw a line straight through the origin just like that, okay, that would be a 180-degree spin this way or a 180-degree spin this way. Let's take a look at the next one and see if we can match this up. 0, -2. 0, -2. So that's C prime. Okay, notice how we used to be going up 2, now we're going down 2, exact opposite direction, like doing a 180. And L is 5, 0 now, so L prime is 5, 0. So over 5, don't go up or down, so this is going to be L prime. So take a look at that. Now, that might look a little bit like a reflection, but it's not. There's no way we could do a mirror image. There's no way we could fold this and have it lie on top of each other. What we've done here is we've basically spun this around. It used to be pointed in this direction, and now it's pointed in that direction. So this is a 180-degree rotation. So rotate 180 degrees. And again, we're always rotating about the origin, so you don't have to put origin on every single one of these. We're going to rotate about the origin. Okay, well, let's talk about the rules for this now. We've actually done an example of each type. So here's what happens when we do a clockwise rotation. We're going to switch the x and y, so this is going to be y and this is going to be x. And because we're going clockwise, kind of going to the right, if you want to think of it that way, the x becomes negative. Okay, now if you want to go back and check and see that that's true, it is. To go counterclockwise, we're going to switch the x and the y, and you might want to take a guess at what happens here. If we want to go to the right, we switch the x coordinate to a negative. If we want to go to the left, we're going to switch the y coordinate to a negative. And this last one was an example of a rotation about the origin, 180 degrees. All we do is we change the sign of each one of them. So the x and y get to stay in the same place. We just multiply each one of them by a negative. Okay? So for example 3, and you've got some on the assignment this way, the good thing is they've already got the pictures for you. But we do have to come up with two parts of the answer. We have to come up with a function or a mapping for this, and we have to come up with a description. So I'm hoping that based on what we've talked about up above, that this isn't too bad. It does say write a function and a verbal description. Remember to write new and old next to the pre-image and the image. And you can also put your pencil tip at the origin and rotate the paper in the direction of the old to new to see if the figure was rotated clockwise or counterclockwise and how many degrees. So I'm going to write old. This is the old one, and this is the new one. So I'm going to go ahead and do that. I'm going to put a pencil right here, and if we were to spin this to go from old to new, we would be going that direction. So stop and think about this. If we're going that direction, that's going to be the counterclockwise direction, and we only spun 90 degrees. And if you have any trouble seeing that we only spun 90 degrees, you can do this. Draw a line from one point to the origin and then to the new point and the origin, and you'll see that that's 90 degrees right here, and we rotated that way. So this is a counterclockwise rotation of 90 degrees about the origin. Counterclockwise rotation of 90 degrees. Okay, so rotate 90 degrees counterclockwise. Okay. And then we can look up here to remember what the rule is for that. So if it's 90 degrees counterclockwise, remember, if we're doing a 90-degree rotation, the x and the y switch. So we're going to do a y and then an x. And if it's counterclockwise, it's the y that changed sign. So I'm going to put a negative in front there, and that matches up with this one. Okay, let's take a look at this guy right here. We've got the old one and we've got the new one. Again, I'm hoping that you can kind of see this. This used to be V, and now this is V. So we've kind of rotated that way, rotated this way, rotated that way. If you have any trouble with this, again, you can just draw a line from the origin to the old point. So this was J, and this is J prime. There's 90 degrees right here, and to go from the old to the new, it has to go that direction. So we've got 90 degrees right here, and it would be going around in this direction here, so that's going to be clockwise. So we're going to write rotate 90 degrees, and we'll just write clockwise here. And if you remember the rule here, with the 90-degree rotations, it's just switch the x's and y's. So we're going to do y here and we're going to do x here. And if we rotate to the clockwise, the right direction, it's the x that changes. So I'm going to put a negative there. And then you can probably guess, because there's only 3 rotations that we're talking about, which one this is. Notice that this is pointed downward and this is pointed upward. So if we were to draw a line toward the origin and then over here, see how they're in exactly the opposite direction? 180 degrees over here or 180 degrees over here. So this is a 180-degree rotation. So this is 180-degree rotation, and I'm going to write about origin here. And again, you don't have to do that on every single one of them, because that's the only type of rotation that we're going to talk about in this particular class. And then remember what the rule says. Here they switch, but on this one they don't switch, but they do change signs. So let's take a look up here. They don't switch, but they do change signs. So this is going to be negative x comma negative y, and there's our mapping rule. There's our function. Okay. Now, If we take a look at example number 6, it says graph the image of the figure using the transformation given. So we want to do a 180-degree rotation about the origin. Now you are absolutely welcome to write down the points. So if we were to take V would be the point 4, -1, and then we could transform that to V prime. And remember, it says 180-degree rotation, so we just multiply each one of them by a negative. So this would be -4 and 1. So -4 and 1. The other thing that you can do is you can just go right through the origin. So let's go right through here. So this is like this. So we go over 4 and down 1. Instead of going over 4 and down 1, we're going to go back 4 and up 1. So there's going to be V prime. Okay, instead of going left 1 and down 2, we're going to go right 1 and up 2. So notice we're always drawing a line through the origin. It's kind of just like using those slope points. So this would be J prime. And instead of going right 2 and down 4, we're going to go left 2 from the origin. Left 2 and up 4. So that's going to put us right here. So that's going to be K prime. So take a look at this. All right. And you'll notice that the J rotated around, the V rotated around, and the K rotated around. Instead of being pointed down here, we're now pointed up there. So if you need to write down the points, go right ahead. I'm going to go ahead and do that on this one. If you notice that we can just kind of draw a line right through the origin and kind of reverse that slope count, if you want to think of it that way, that's fine. On this one, I'm going to do S, let's see, U. We'll do U first. So U is... let's see, -2, -1, because rotations about the origin that are 90 degrees, those are a little more difficult. -2, -1, and X is -4, -2, and S is -5, 3, so -5, 3. And then to make these, we're going to do a 90-degree clockwise rotation. So remember what happens there. The X's and Y's switch. So I'm going to do a U prime, an X prime, and an S prime. Okay. And with a clockwise rotation, the X's and Y's switch, but the X gets multiplied by a negative. So this one's going to come here. So that's going to be a -1. And then we're going to multiply by -1 here. That's going to be a 2. So they switch. The Y comes over here. The X gets multiplied by a negative. The Y comes over here. The X gets multiplied by a negative. Okay, so let's go ahead and graph these. U prime would be -1, 2, so back 1 and up 2. So there's U prime. X prime would be -2, 4, so back 2 and up 4. So we're right here. So here's X prime. And then S prime would be 3, 5. So over 3 and up 5. So we'd be right there. So there's S prime. So this is what it looks like. Now you'll notice that we've kind of got this cone shape pointing up and to the left. Now we've rotated it and it's kind of pointing up and to the right. So this is kind of a rotation over here. So there's our 90-degree clockwise rotation. So we've got that one figured out. We've got these marked and everything. And then the last question here is, what do you notice between the pre-image and the image? So the old and the new. The old and the new. Well, what do you notice about the orientation, the size, and the shape? Well, again, they may be oriented differently. So this has the K pointing down, that has the K pointing up, this has the S pointing up and to the left, this has the S pointing up and to the right. So the orientation is different, but think about the size and the shape. The size and the shape is exactly the same, so they are still congruent. Okay, so they're still congruent. So this is a rigid transformation. It doesn't change the size or the shape, but it does change the orientation, but still the same size and shape, still congruent. Okay, lots of stuff to remember. I know this kind of takes a while to sink in. Practice and you'll be in good shape.